Okay, going to try question 14 from the 2019 paper 2. This is quite an interesting one. We've got quite a lot going on here. I'm going to do all three parts, starting with part A. So in part A, we're given the substitution that u equals 4 minus the square root of h. I'm going to differentiate to get du dh equals, okay, that's minus a half h to the minus a half. That's nice, but it would be more useful if I was able to write it in a different form, so that I could have, let's make the dh look like a dh. If I was able to say dh equals, so I'm going to rewrite this, a few steps involved. Firstly, I'm going to say du dh is equal to minus a half times 1 over the square root of h. In other words, that's minus 1 over 2 square root h. So du equals minus 1 over 2 square root h dh, or to put it another way, du minus du times 2 square root of h equals dh, and that's the thing I need for later on. Okay. Secondly, I'm going to rewrite this so I can say square root of h equals 4 minus u. Okay, good. So that's all of those preparation bits. I'm now going to look at the question again, and it asks me to integrate dh over 4 minus the square root of h d8. Okay, I've got the dh already there. So that gives me, if I'm replacing everything with u's, on the bottom I'll get u, and on the top of the function I'm going to get the thing that I wrote down here, du times 2 square root h. So that's 2 minus 2 square root of h du. Replace the square root of h with 4 minus u. Minus 2 times 4 minus u, all over u, du. Expand, and we get the square root of minus 8 plus 2u, all over u du. Can't do it in that way, but I can split that into separate fractions to make it easier to work with. Minus 8 over u plus 2. 2u over u cancels down to give me 2 du. And now that's easy enough to work with. So that's going to give me minus 8 log u plus 2u plus c. Remembering that u is a value that we're given, minus 8 log of 4 minus the square root of h, plus 2 times 4 minus square root of h. Just replace that with the curly bracket, plus c. Right, minus 8 log 4 minus the square root of h, plus 8 minus 2 square root of h plus c. Just quickly, that and that, combine them together to get a different variable, which I will call k. So I get minus 8 log 4 minus the square root of h minus 2 square root of h plus k, which is what we were asked for in the first place. Okay, all the way back up here. That's the thing that we were given. 6 marks, well done us. Okay, next up, part B. So in part B, find the range of the trees. Right, height has to be positive. The rate of growth, I mean, trees don't shrink, assuming that trees don't shrink. dH dt is going to be greater than 0. Therefore, 4 minus the square root of h is going to be greater than 0, which gives me that h must be between 0. I can't have a negative number in the square root, and 16, because I'm assuming that it's going to be greater than that. So 2 marks for that. Arguably, less than or equal thans. Okay, I think 0 and 16 are the limits. I'm happy with that. Right, on to part C. We have this function, and we're asked to find, given one of the constraints just here, that if t is 0, h is 1, we're asked to demonstrate, to find the height, find how long it will take to reach 12 meters. Okay, now find some space to work in. Okay, so start by writing out the question again. Part C. We have dh dt is equal to t to the power of 5 over 4. I'm going to write that as t to the 0.25. T to the 0.25 times brackets 4 minus square root h. 4 minus square root of h, familiar, all over 20. Okay, differential equation time. And what we're trying to do, we need to remember that if t equals 0, h equals 1, and we want to find when is h equal 12. That's the question we're solving. So let's fire away into this one. All right, I'm going to begin by separating the variables. So that gives me the integral of 1 over 4 minus the square root of h dh is equal to the integral of t to the 0.25 over 20 dt. Luckily, I've already done this question. That's part A. So we know that that is equal to minus 8 log 4 minus the square root of h minus 2 times the square root of h plus some value k. Let's leave that till later. Okay, we'll resolve all of the constants on the other side. Okay, power goes up by 1, t to the 1.25. Divide by the power. Right. Pausing for a second while I work out 20 times 1.25. 25 plus c. 21 1.25 quarter of, yes. Okay, so that's the information we have. We need to find out what c is. We need to find that value, and to do that we're going to use the information we have up here. If t equals 0, h equals 1. So that gives me, let's just do that, if t equals 0, h equals 1, therefore minus 8 log 3 minus 2 square root, so I've just substituted in 1 for the h values, equals c. Okay, I think we're happy with that. Good. And now to resolve, solving this, we want to find h is 12. So I'll go ahead and say if h equals 12, we get minus 8 log 4 minus the square root of 12 minus 2 times the square root of 12 equals t to the 1.25 over 20. minus 8 log 3 minus 2. Okay, I can calculate this, add that to both sides, so we get minus 8 log 4 minus square root 12 minus 2 root 12 plus 8 log 3 minus 2. And if I times all of that by 20, that equals t to the 1.25. I'm going to get the calculator on that. Well, to be honest, I did that earlier. So I got 221.279 equals t to the 1.25. And finally take the appropriate root. That's the 5/4 root, or that to the power of 4/5. And we get t is equal to 75.2. Okay, hope that works.